Thundersnow Industries designs and builds snowmobiles for riders around the world. From the Alps to the Canadian backcountry, Thundersnow's latest vehicle, the Snownado, is equipped with sensors that capture real-time performance data, giving their team key insights about product performance, reliability, and customer experience. One insight gleaned from this data is a concerning trend of spindles requiring service or replacement much earlier than previous models, forcing engineering to urgently improve the design to remedy the problem and prevent damage to the brand. In the past, Thundersnow's engineering, manufacturing, and service teams have operated in silos, each with access to only their own data sources, causing a variety of problems in today's complex manufacturing environment. But with PTC software, Thundersnow can aggregate each team's siloed data with real-time performance data from Snownados, combining critical data from engineering, manufacturing, and the product, forming a digital thread of complete product information. PTC's digital thread creates a closed loop between the physical and digital parts of the Snownado product lifecycle, giving Thundersnow all the information they need to solve the spindle problem quickly. Their goal is to use the digital thread to break down silos, to get the right information to the right teams at the right time and in the right context so they can understand exactly why the spindles are breaking. Thundersnow uses telemetry and fleet monitoring data to remotely find the root cause of the spindle problem. The product reports show a roll-up of how all vehicles for specific models are being used in real time, along with service data collected from dealerships. From the parts report, the team notices that the spindles break more than any other part, and the breakdowns can happen within only 90 days of service, meaning the existing part is either faulty or not meeting the demands of some riders. This data also shows that Snownados with the spindle fail sooner, after less mileage, and with more alerts before coming in for service. To figure out why the spindles are breaking, the team starts with a comprehensive product overview of Snownados in the field. This report shows a combination of vehicle usage data leading up to the part failure, along with service information logged during the repair. From this report, the team notices that there were a high number of triggered belt slips and over-rev events leading up to the failure. Expanding the weather data for a cluster of failed vehicles, the team also sees that spindle breaks occurred after hard frosts in icy weather conditions. With this data, Thundersnow concludes that the spindle breaks coincide with extreme riding on rugged terrain during inclement weather. Knowing the root cause of the spindle breaks, they filter their entire fleet for spindles with excessive belt slips in a single ride. This reveals a key insight. Over 10% of Snownado riders fit this extreme riding profile. The team now has the real-world data they need to inform a problem report, including an updated set of loads informed by actual vehicles in use. From design and engineering to manufacturing and service, Thundersnow's design team will use telemetry data and the updated set of loads from their investigation to design a stronger spindle. Because Windchill understands the associativity of the spindle, the engineering team can easily collect everything related to the part so they can consider all changes, from design to process planning and service documentation. This enables them to execute the change across their entire business using the digital thread, enabling the broader enterprise to utilize this data and collaborate earlier in the design process. The team also loads real-world data captured by Snownado strain gauges directly into the Creo model, so they can optimize and drive product design. The spindle's 3D model contains all the measurement, tolerance, quality, and characteristic data needed to define the product. This single source of authority is one of the backbones of the digital thread, helping everyone, from designers and manufacturers to external suppliers, communicate in a closed-loop environment so they can produce the most cost-effective and highest quality spindle. Thundersnow will use the engineering BOM and the fully annotated 3D model to validate the manufacturability of the revised spindle design. Windchill's BOM transformer dynamically updates the spindle's manufacturing BOM, giving engineering and manufacturing a common view of spindle data. Using the updated manufacturing BOM, the team develops the process plan, which includes the manufacturing instructions, tools, materials, and control characteristics for every product configuration. This MBOM data is added to the digital thread, allowing it to be accessed by other systems like MES or ERP to update the spindle's material master record or digital work instructions. This MBOM, along with the process plan, helps them validate manufacturability early, shorten time to production, and reduce overall product development costs. Thundersnow will use the process plan and the MES scheduling data to give the shop floor the information they need to manufacture and assemble the new spindle. From the process plan, they automatically create digital work instructions, which contain the control characteristics for the specific configuration of the product, giving operators up-to-date, accurate data in a single, unified interface. Digital work instructions are used to communicate bidirectionally with smart tools, resources, and PLCs, sending the right settings and performing quality checks in real time. This helps operators focus on the actual work of assembly. Along the way, the results from the digital work instructions and all the quality assurance checks are recorded as an audit trail in PLM for traceability. Thundersnow is not only capturing assembly data from smart tools, but general manufacturing production and environmental data from PLCs, sensors, and other systems, from production time and scrap to humidity and temperature. Kepware translates this data into a standard communication language and adds it to the digital thread, making it accessible and understandable to more than just control engineers. With operator entered and automated manufacturing production data, Thundersnow can see how efficiently they're assembling the new spindle. Learning that the new spindle's cycle times are longer than before, they use this data to find the root cause for their time losses, then determine and validate specific, targeted actions to optimize its assembly. With an understanding of the root cause, they request a spindle redesign from engineering, updating the digital thread with a problem report for a new design to improve ergonomics and decrease cycle times. This manufacturing production data is continuously updated on the digital thread, informing other continuous improvement initiatives. Thundersnow will use the Snownado's engineering and manufacturing data to create accurate, up-to-date digital and AR service work instructions to replace the spindle. Thundersnow leverages the same CAD and PLM data used for manufacturing instructions to maintain the service BOM and create interactive service work instructions. These help technicians familiarize themselves with the spindle repair, understand the required tools, materials, and parts. The team deploys these work instructions as AR experiences, linked to the new spindle requirements. The experience specifies target values and requires technicians to record the actual values from the experience for the serialized audit trail. The team will also track the old spindle for sustainability to support their circular economy initiatives. With this data, they proactively offer remote service, like flashing software updates designed to reduce belt slips. They can also define condition-based maintenance tailored to extreme riders and stock replacement spindles at specific locations and times, like service centers near popular rugged trails. With the updated service BOM, service record, and product telemetry data, Thundersnow gives technicians the information they need to provide a best-in-class service experience. Informed by data on the digital thread, Thundersnow efficiently solved the spindle problem and discovered an entirely new market of extreme riders with demand for a high-performance model. They're unlocking digital transformation, not just within their own teams, but across the entire value chain, from design and manufacturing to sales and service, giving their riders a world-class experience on and off the trails.